Hi everyone. Sorry for the inconvenience. My audio didn't pick up in the video, so I am creating an intro separately. Hi, my name is Harsh, and this is my assignment one submission for cloud computing CS441 at UIC. And to give a reference about it, I have created my project locally, and I have deployed my jar file to the AWS, and remaining things you're gonna see in the video. There's a jar file which I have pushed in my bucket, and there are a few other things which I have also pushed to my bucket, which I'm gonna go through. So I have pushed the MSR corpus, the PDFs which we are gonna use to RAG our model. Um, and other than that, we have an input folder. In that we have two text files. So um, each of these file has paths to the PDFs. So the first one, file list.txt, has path of all the 608 PDFs which we will use to RAG our Ollama model. So, but for the sake of the demo, we are gonna be running on file list try.txt. This file has 10 paths of the PDF, so I can open it. I can show you. It just has the path where the PDFs are, and when you go back to it, and when you go back, you can see one more folder, Bootstrap. So Bootstrap folder has a bootstrap.sh which we have created, which we are going to be using initially when we will be running our cluster, so that we can download the dependencies and start them. So in our case, we will be downloading the two Ollama models, which will be MXPAI embedded large and Tiny Llama. We will be using them for our embedding and search query. And other than that, we will be in that bootstrap.sh, we will be setting the Java version and setting the path and all the things which is required for a jar file to run. So so now we can so now I am on my cluster. I will create a cluster, and you guys can see I will select EMR 7.0, which has 3.6. We will be using M5.2x large, M5.2x large. Let's say M5.2x M5.2x large, and then we will be setting this to 30, and we will be uh, setting a bootstrap action over here. Over here we can add the path of our bootstrap.sh, and we, in cluster log, it will be going through our S3 bucket. So you can see all these things in this. You can set uh, we will be doing one more thing. We will be going in security, and we'll be selecting a key. So this is just for the demo purpose. I'm showing what we have to do, because after we create the cluster, it bootstraps and it takes some time to download all the dependencies and everything. So for the sake of demo, I already created a cluster so that we don't have to uh, waste time on waiting for the bootstrapping to happen. So this server is active and running. You can see our dependencies and everything is running. This is our S3 bucket location, which we are going to be using. And now what we're going to do is that we are going to be running a step. So we will add a step. So now name, we'll we'll first run our sharding. So basically what we are going to be doing is that we will extract the we will take our PDFs, and then we will basically create 4 shards out of it. So which shards which will help us to later do the search queries. Shards, we're going to give the name to it. We're going to browse through our, then we will set the command for, we'll write the argument. So basically this is the argument which tells that this is the place where my file list or try is, and this is the place where we want uh, this is the place where we want our output to be, and these are the places where our shards will be created, uh, our shards location. So basically uh, it's the shard, this output will have the location of our all the reducer and how it has divided the PDFs in chunks, and this will have the indexes and everything of those specific files and words. uh, so we will first add this step. We can add one more step for us to create a vocab. We will browse. You go to this, select, and then so like how I told you that we have, it's gonna be split in four shards. So those setting which the those four shards what we have decided that we have done in our application.config file, as you can see over here, that we have set the shards number to 4, and we have set our embedding model to be mxbi large. So now we will run this step 2. So now if you refresh the, so now you can see our Hadoop charge is running, and this is still in pending. So till the time our job is running, what we can do is that we can SSH our cluster so that we can access our cluster from the terminal. So what we are going to do is that we are going to click on connect to the primary node using SSH. We are going to copy this host name, and then you're going to, in Windows, you need to run putty. So you go to putty session, you write your, you copy paste this host name field, you go to SSH, you go to auth, you go in credentials, and then you have to select the key. So this is the key which I initially, when I created the cluster, this was the EC2 key which I used. And now we are gonna open this. So when we open this, we we get a terminal like this. That means we are connected to a cluster. So now what we are gonna do, we are gonna push from our local, from our Scala terminal. We are gonna push from our Scala terminal to our cluster so that we can run our jar file over there. So again, we are gonna copy the host name session. We are gonna come over here. And as you can see in this, you write scp key2.pem. Key2.pem is the conversion of our ppk file to PEM format, and it has the path to our jar file. And after that is the host name of our AWS cluster. It we have to write yes. So uh, on my ISP there's some issue regarding pushing it, so it takes multiple try, the connection gets reset, so I just need to go through the hassle of doing it multiple times. So once it's done, I'm gonna show it to you. It will look like a cut in the video, but what happened was that I had set the ideal time in my terminal, and and my cluster got terminated. So then I ran the jobs again, and I did one more mistake when I was running them. My vocab was working with the file list.txt, which had all the PDFs. So we were getting the vocab of the whole PDFs, and on the other side we were making the shards for the demo PDF. So I ran both the jobs again. You guys can see that they both ran. The leucine shards are again made, and they are being sent to S3 bucket. And same goes for the new vocab.csv. We have a new folder MR10 which we will have in our S3 bucket, which you guys can see it has the new CSV. Now going back to our cluster, we have this, and then I did set my putty again with the new cluster and everything, and we are in I SSH'd the cluster, and we are in the terminal, and we have sent a jar file to the terminal, to our ear. My bad, I might not be able to explain it properly, but uh, so basically what I've done, I have recreated the whole scenario again. I have SSH'd the our cluster, and that is being opened to putty, and we are in the terminal. I have set the Java path 17, and now what we're going to do is that we're going to call a leucine shard from S3 bucket to our EMR. So we are calling, so basically, wait, let me stretch it out. So basically, we are calling from our 441 bucket an out a leucine shard to our EMR. So when you're going to do this, now we have our leucine shards in this. We can just check it. We write ls, and yeah, we have leucine shard. Now we are going to call vocab2. Now we are going to call vocab, and we got our vocab2. We can again verify it. We have our vocab2, and now we are going to run our embedding file. So basically we are gonna make embedding with the vocab.csv. So what it is taking, it's a jar file, and we call token embed, and we are giving it the vocab.csv, which is over here, and it's going to create token embedding. So it is basically creating embedding for 4,969 tokens. It will take, I think, few minutes for it to create embedding. So after our embedding is being done, then we are gonna send the token embedding file which we create in our EMR back to our S3 bucket. So we will just wait for the time being. Yeah. Yeah. So guys, now we have our token embedding which has been created. Now we can check it is over here. Now what we are going to do is that we are going to send this token embedding back to our S3 bucket which we created in this EMR. So we are sending our token embedding, and it's been uploaded back to our S3. We can just go and verify it once. So once we are over here, you can see that our token embedding.csv is created. And now we are back to our terminal. And now what we are going to do is that, again, when we created this token embedding, it was created in a folder format. It was created in a folder format. So now we are just, because we sent it to our S3 and converted it to CSA, we are just going to call it back from our S3 to back to our EMR. And now we will have, you can see that we have a token embedding and token embedding.csv. We did that so that we can get the token embedding in a CSV form, so that we are going to use that later for a token neighbor. And now what we are going to do is that we are going to try to run the search. So basically we can, we are giving a jar file, we are giving it search command, and the questions is like what are bandits, or we can say we can do what is cloud, and it is getting Leucine shard which is there in our system, and we are setting the k neighbors as 5 and we are ragging it. I have done the implementation with rag and without rag too. So now this is just gonna create request an embedding for the text, and then it's gonna find the k nearest neighbor from the leucine shards, and after that it's gonna send those text combined text to tiny llama, and then tiny llama will give us an answer. So yes, so this is like how you can see the raw Ollama response was this small. We sent a tiny llama this whole message, and this is what we got the answer is, and the sources which are used from these like top 5 neighbors were these, and this is for the search. Now we can create our token neighbors. Now, so basically now what we're doing is that we are creating neighbors, and what I have done is that rather than computing it for all of them token neighbors, I have constrained it to a uh, top 2000 words. So the words which have more frequencies, so those on top 2000, we are going to find the neighbors for them and their cosine similarity. So now once we have created this CSV, we are going to send this CSV back to our S3 bucket. And now we are uploaded to our S3 bucket. We can come here, refresh it. It's in token neighbor CSV. We can open it so that you guys can look what values are there in it. So it has the token and neighbor and the score for them. So you can see the was the most used word. So we basically got top 10, basically 10 top neighbors for them. And that's what we have done for the off and all those words. So this is our token neighbors. And then after our token neighbors, then we are gonna then after that what we are going to do is that after we get the after we get the neighbors, we need to create the embed eval. So in embed eval we are going to get two things. We are going to get the analogies and similarities. So for that we are just going to write this. So as you guys can see that we have basically set these pairs. uh, as we didn't have any of these pair in our embedding.csv, it was not able to find. But for the one which it was able to find, for data information, it got 0.48. For bug defect, it got 0.45. There was no cat and dog, so it's saying missing in embedding.csv because there was no cat and dog in the embedding data set what we have. Same goes for car and automobile, same goes for king and queen. But we have function, method, graph network, algorithm, procedure, and their cosine similarity. And for analogies, what we try to do is that again same thing. It try to use these words and try to find whether whether we have this pair or not. But when we ran over all of them, it skipped, and because these analogies are not there, it tried with class, object, function, and logs, and the expected was call, and the score for that was 0.73, but it was not call, it was logs. And same for bugs, fix, error, undocumented. So expected was patch, but what we got was undocumented. So again, that is also false. These analogies and these similarities are being shifted to a CSV file, so we can again send these CSV back to our S3 bucket. So we are just going to write this and we're going to send it. So now both of them are loaded. Now we can see the CSV Over here, we will have embed analogy. We can open it and see. So it has for the missing pair, it didn't find it, so it didn't add it in the CSV. So for the one which it tried, it was class, object, and function. It expected a call, but what we predicted was logs according to our similarity score, and the score was 0.74 for logs, but it was not correct, so it's showing is false. And we can go and do the same thing for similarity. So similarity for data information, the similarity is 0.48. For bug defect is 0.45. For repository database is 0.53. Like how you can see the cosine similarities. And for final thing, what we can do is that we can try to run the test. I think that is something which we haven't showed till now, so we are gonna just run test. So it basically checks whether the logger is working, whether the chunking is working, and the tokenizing is happening in vector normalization. So that is my complete implementation of assignment one. It was a bit cluttered, but because of time constraint, I wasn't able to record it properly. I'm sorry.